Welcome to Lesson 2. It's time to get our hand dirty and build a cluster from scratch. When you're first learning, you might use tools like Minikube or Docker Desktop. These are fantastic because they spin up simple single node cluster where one machine acts as both control plane and worker. While this is a great for quick playground, it doesn't reflect the real world setup and hides one of the most important installation concepts. So in this lesson, we are going to build more realistic cluster. We'll set up on dedicated control plane node and then join a separate worker to it. This is a topology is a foundation for building scalable and highly available cluster. The tool we are using to achieve this is kubeadm. kubeadm is official command line tool from the Kubernetes project that helps you bootstrap the best practice cluster. It automates the complex process of getting control plane components running and allow new nodes to join the cluster securely. Our installation process will follow these three main steps. First, we will initialize the control plane on our dedicated master node. Second, we'll install a special piece of software called pod network, which is crucial for communication inside the cluster. And finally, we will join our worker node to the control plane to complete our cluster setup. Before we jump into the hands-on installation, let's quickly go over the minimum requirement for the lab environment we will building. Ensuring your machine meet this baseline spec is crucial for smooth setup. First, for hardware, you'll need at least two machines. One act as a control plane and another one act as worker. The control plane node does more heavy lifting, so it needs at least two CPU cores and 2 GB of RAM, though 4 GB is highly recommended for best performance. The worker node can be a little lighter. For the software and OS configuration, all your nodes should be compatible Linux distribution, and they must have a container runtime like containerd pre-installed. A critical requirement and one of the trips of many beginners is that swap must be disabled on all nodes. Kubernetes is designed to manage memory directly, and having swap enabled can lead to the unpredictable behaviors. Finally, a few important notes. Please remember these requirements are for learning lab. A real production cluster would be significantly more resource for highly available performance. And kubeadm will not install and manage kubelet or kubectl for you. You need to install them with package manager or download and install them directly. In this course, we are using the package manager for installing those components. All right. With the requirement clear, let's move to the actual installation process. So I'm switching to terminal. Here you can see I'm already connected to the machine, so I'll connect again. So the first thing I'm going to do is open shell in my control plane machine. I've already provisioned a virtual machine for this, which I've named kube control plane 01. So I'm gonna install the requirement at the moment. So the engine of our cluster, which is container runtime, in our case containerd. So yeah, this is the command. So I'll copy the containerd command and I'll install the containerd. So meanwhile we are waiting for that to be installed, I'll copy the next command, which is the configuration for containerd. Because by default on the Debian, my distribution right now is Debian, doesn't have the, if I'm showing you the configuration, you can see the configuration has two major issues. One issue is a bin directory, which is user libcni. By default, the kubeadm is using user opt bin CNI, not user lib CNI. So this is the important thing that should be fixed. Another issue is that by default, the C group is not enabled here. and it's necessary for our cluster to be running all the time. So to enabling the etcd, I'm gonna use this, and then changing the configuration. Okay, and then restarting the containerd. So I can cat the command again, and then you can see right now then we have the runtime and we have the sandbox images set to the latest version of Kubernetes at the moment. So it's time to installing the kubelet and kubectl and kubeadm. So now that the runtime is ready, it's time to enabling and installing the kubelet. After the program, I'll put these commands on course so you can use them for installing the components. And then in the latest step, we need to enable the IP forward in kernel, because we want to make sure that Calico is able to use the forwarding in the system. So, okay. And now it's time to pulling the images for control plane. So I'm gonna use this command, which is pulling the images from the image registry of Kubernetes. As you can see, registry kts.io kube API server version 134.1. And the rest of the necessary components that we already covered during the HA setup, like what kind of components are in Kubernetes and how they are important in Kubernetes setup. So when the pooling is finished, we are gonna create our first Kubernetes cluster. I think this is the latest, the last image that we need to pull. Okay, it's all done. Now that we are on our node, the magic begins with a single command, kubeadm init. This command will install and configure all the control plane component we talked about in lesson 1, the API server, etcd, scheduler, and the controller manager. We need to provide a couple of important flags. First one is the pod network CIDR. Pods in Kubernetes get their own IP addresses, but they live on a separate virtual network overlay. This flag tells the cluster which IP addresses ranges to reserve for this pod network. And second is API server advertises addresses. These tell the API server which network interface and IP addresses on this machine is should to use to communicate to the rest of the cluster. Especially this is important when you have multiple interfaces on your machine, and then you want to advertise the basically API server on a specific IP addresses on your machine. Like imagine that you have 3 different physical connection from 3 different vendor, like internal, external, and then you want to separate. You don't want to expose your API server on the external, and you want to keep it on internal network. So you will specify the API server advertise address. So I'll use this command since I have this IP address here. So you can see that my IP address is 192.168.1.200 in my local area network. I'll use this as an advertised network, and I will use the 172.1.18.0.0/16 network as our virtual network, because this is not used in my home setup, so I can use it as a network. You can see it's up and running and creating a cluster. So kubeadm now is running series of pre-flight checks, generating certificate, and starting up control plane component as static path. All right, it's finished now. Pay close attention to the output. Kubeadm gives us some very important instruction. First, it tells you how to configure kubectl, so you can start managing the cluster as a regular user. We'll do in the moment. Second is most critically, it gives you kubeadm join node command. This command contains a secure token and is the key for the our worker node to join the cluster. You absolutely need to copy this full command and save it somewhere safe for next setup. So if you ever lose this command, don't worry. You can always regenerate a new one by running kubeadm token create print join command on the control plane node. I'll do that later. So let's follow the instruction to get kubectl working. You just copy and paste these three commands. Well, since I'm using the root user here, my ID is root, I don't need to basically copy paste or do any special thing. I just can use the export kubeconfig as it suggested to me. So I can just like use the alias which I use for Kubernetes kubectl, like kget nodes, and then I'll see that the kube control plane 01 node is here and it's not ready. So the next step is there is more crucial step before our control plane is truly ready. The output reminds us you should now deploy a pod network to the cluster. As you can see, the node is not ready. So right now, our cluster has no networking layer for the pod. We need to install a CNI plugin, which stands for Container Network Interface. There are many popular options like Calico, Flannel, or Cilium for the demo. We'll use Calico. The installation is usually as simple as applying manifest using kubectl. So first I'm downloading the manifest from the internet. This is the latest version of Calico, and then I'm gonna apply this on the node. So this will create some custom resource definition stuff like that. So if I'm getting like the pods on all nodes, we can see that the control plane, the Calico CNI is initiating, and soon we should have containers ready and running on the cluster. These pods like coordinates, this is depending on the CNI. So after the CNI get initiated, this should get started. So I can describe the pods. System. As you can see, so yes, as you can see, the coordinates pods are running now because the node is ready, because the kubectl, because the Calico is running. So the node status is ready. So this command fetch the manifest for Calico and install the whole thing. The next step, as you can see, everything is running and we don't have any issues. All pods are running. The next step is joining the worker node. Make sure that before joining nodes, everything is ready and running on the controller node, so you are not facing any issues meanwhile. Now I'm gonna SSH into the worker node. This is the worker node. So I'm gonna repeat the same thing that I've done for controller. Instead, I'm not creating the cluster here. I'm joining to the cluster. So every requirement that we did for master node should be done here as well. So installing the container D, configuring the container D, installing the kubelet, and then enabling the IP forwarding and so on, and enabling the date. And that's also an important part of this. So this will install the requirement for us. let's find the join command in the terminal. As you can see, this was the join command, so I'm gonna use this for joining the worker node to the command line. So let's use this. Okay, now the worker node is running. So let's go back to the master node and get the let's define the alias again, and then get the nodes and see is it running or not. Okay, I need to export again the kube configuration. As you can see, it's not ready, but it's joined to the cluster. So if I get the pods after initiating the Calico daemon set on this node, this should be also running. Okay, it's in the second phase of initiating, so it's pretty close to finalizing the installation. Let's wait a bit. Okay, now it's running. Let's get the node, and as you can see, the node worker 01 is ready. So let's back to the presentation. So congratulations, you have just successfully bootstrapped a multi-cluster Kubernetes using kubeadm. We initialized the control plane, installed the CNI for pod networking, and securely joined a network worker node. Now you have a solid fundamental cluster ready for you to start deploying application, which is exactly what we will be exploring in upcoming lessons.